But in robotics, very often we cannot use breakpoints because we have this distributed nature and ROS. So we can, if we stop the execution of a controller, then the entire system starts behaving strangely. And so the only way we can really debug sometimes is logging a lot of information and watching this information offline.
This is a conversation with Davide Faconti, who is the creator of BehaviorTree.CPP and Plotjuggler. BehaviorTree.CPP helps you organize complex behaviors in, for example, a robot or video game, and Plotjuggler helps you understand your data to make debugging faster and easier. This is especially useful in complex systems like robots, where there are many parts running at the same time. Both BehaviorTree.CPP and Plotjuggler have wide adoption in the ROS community, and both of them have largely been designed and coded up by David. What's more, he has done them both as side projects, describing Plotjuggler as a love letter to the robotics community. In this interview, you'll learn about BehaviorTree.CPP and Plotjuggler, both of which fill important gaps in the ROS ecosystem. You'll also learn more about how David creates and thinks about side projects so your side project can have more impact and more users. I'm Audrow Nash. This is the Sense Think Act podcast. Thank you to our founding sponsor, Open Robotics. And now here's my conversation with Davide Faconti.
So my name is Davide Faconti. I've been working in robotics almost 20 years now. So I've done a little bit of everything. Worked on humanoid robots for kind of half of my career. And I worked on low-level hardware interface, mechanical design, high-level task planning, navigation, manipulation, basically everything you can imagine in robotics, maybe with the exception of drones. I think I've done it in these 20 years, so I'm very lucky.
Was it mostly in industry, mostly in
Yeah,
academia?
mostly in industry. So I had a couple of projects that were more into this, H2020 Horizon, publicly funded project in Europe, but I think I prefer to work in the industry, so building products.
Why?
I guess that it is a different kind of incentive. So when you are in research, your intrinsic motivation is about making new discoveries and share this with the others. But I think that also nowadays, I hope nobody get offended by this, but nowadays the publication system give the wrong incentives. This publish or die. And I think that for me, at least, the best benchmark of my work is if anybody wants to pay for what I did, means that I did a good job. So you can't hide in front of a client. You can't you know tweak the value and say, yeah, that works more or less. It works. No. I mean, if the robot fails 1 out of 10 times, it is unacceptable. So for me, at least. The reward is that I see the usefulness of what I do, so I see it in action, and also it pushed me to get to a level of quality that is beyond the proof of concept. It's really about building robust products, and you need to do innovation, right? So there's a fine line between innovation and research, right? I think that I like more innovation. That is a more pragmatic thinking about I have a problem and I need to solve that problem. And if there's a boring solution, I'll take the boring solution. If I need to take, to build a new cutting edge algorithm, I'll do that. But I'm very pragmatic about it.
For sure. I thought so. I was in a PhD program
Hmm.
before starting at Open Robotics, and there was one time I was working on behavior change where robots would help facilitate behavior change in people, and I found something that worked really, really well, and I wanted to do that, but we couldn't make a good-looking model around it, and thus we couldn't go with that approach. It was like it would solve the problem that we're motivating for, but it wouldn't be interesting academically.
Hmm.
So I understand the drive for like value as opposed to necessarily novelty. But both are
Yeah,
good, I think, and both have their place.
indeed, indeed. And it's really
Hmm.
about, it's a personal decision, so I'm not criticizing who takes a different direction. But for me, the incentive is to really to see something, being produced maybe in the 100 units, and having the robot doing stuff,
Hmm.
warehousing or whatever.
Yeah. And so we were talking a little bit before we started recording. And so you are contracting at Picnic
Correct.
Robotics.
Yes.
And they make Move It, and it's basically contracting as robotics experts, this kind of thing.
Yeah, yeah, and now there's this exciting thing that is the Move It Studio
Hmm.
platform. This is really a really important moment for a company, so they're pivoting, to this new product-oriented
Yep,
approach, and that is really exciting. So, yeah,
for sure.
personally, I'm working as contractor for other projects, but
Hmm.
it's really nice to work at Picnic.
Yeah, for sure. And if anyone is interested, I interviewed Dave Coleman, who's the
Hmm.
CEO of
Yeah,
Picnic, in an earlier one, and we talked about Move It Studio, which is for supervised autonomy. Correct, David?
correct, correct.
So really interesting space. But the thing that's really interesting to me is you have two large things that you're working on outside of your work at Picnic that we'll
Correct.
talk about during this interview. Can you first tell me about Behavior Tree CPP?
Sure. So this is a project that started more or less 3 years ago, something like that. It was a small project I built for one of these cascade funding European projects. So it was a tiny project with a tiny budget, but I tried to do it very well. And
Hmm.
once again, for me, the success was about the number of people that would use it, right? So when I built this software, I did something that a lot of people forget to do. That is spending maybe half of my time in documentation, tutorial, refining,
Oh.
and the software quality. So usually people focus on the proof of concept and make it work, and then you have a huge entry barrier. So first of all, people need to trust your software to decide that they want to invest time to learn it. So they need
Hmm.
to see the value. And then the lower is the entry barrier, the easier is for them to start using what you built and then
Hmm.
appreciate what you did. So I really invested a lot of time and not just in the functional part of the software, but also on making it accessible to other people. And this also involved creating Groot, that is this graphic user interface to edit and visualize behavior trees. So that really worked extremely well as not just a tool, but I would say also as a marketing Trojan horse. So a
Cool.
way to make to change the perception of people. Say, hey, look, they not only they have the software, they even have a graphic user interface. Oh, let's try it. And then very rapidly they can see, they can build their first behavior tree. So it's really about the perception, in my opinion.
What do you mean, the perception?
About you always think about the return on investment, even if it's not conscious. Say, okay, what do I gain if I take this approach, and how much time do I need to spend?
Hmm.
And there is a universal truth I learned over the year is that
Okay.
doesn't matter how much your value is. So if you have the four quadrants, even if you have a high value but a high investment, people will not try.
Oh, that's
So
like
the only
Lisp, the
quadrant that really
programming
works
language, maybe.
is either low barrier, low return, or low barrier. So the barrier must be low anyway, right?
Yeah.
Because otherwise people don't even try what you did, don't appreciate the value of it. So that is the number one lesson I learned, in my career.
Or some people appreciate the value, but it might be a really small group. I think of the Lisp community with this.
Oh
Like
yeah,
I
yeah.
love Lisp, and it's a wonderful language to do a lot of things in,
Mhm.
like Common Lisp or Scheme or whatever. Um, but it hasn't gotten the same popularity as like C++ or things. And there was an interesting article by someone really embedded in the Lisp community called Worst is Better or something like this.
Mm-hmm.
And they were
Ring a
saying that
bell.
the speed, do you remember it? Or did you read it? Do you know what
I
I'm
think
talking about?
it might be that I read it, but yeah, go on.
The takeaway was very interesting, which was that Lisp was really nice for the programmers, but very hard for the people that implemented on new platforms. And so whereas C++ was a lot simpler for the people that
Mm-hmm.
implemented on new platforms. And so getting it onto the platforms, like this different operating system or this different microchip or this different, whatever it is, it was a lot easier with C++ than Lisp. And that drove adoption because it could be supported on all these different platforms, even though it's kind of difficult to program in for the user. I mean, the errors can be opaque and this kind of thing. And you don't get like great things like macros and whatever.
Yeah.
So I can see like if you want something to scale, or even like artists, which is interesting, like
Mm-hmm.
artists who were able to disseminate their work were a lot more successful than ones who just created a masterpiece, but one person
Correct.
could buy it rather than. So like a lot of great artists were great printmakers, these kinds of things. So this is kind of what you're saying where you need the low barrier to entry for it to scale so that people use it so you can get people invested in it. This kind of thing.
Yeah,
Like, are those
correct.
good examples
And
for that?
and that's true. I think for any good, this is really the history of Ross, right? So this is what Ross did. So if we look back at how everything started, you know, uh, sometimes it seems I'm a old guy now. I remember the world before Ross. It was a dark age. The point is that we had already something like a dozen maybe framework for robotics
They were all
built in
competing.
academia. So
Yeah.
before Ross existed, and I remember one in particular that just make compiling it and installing it was a pain. So
Oh
you
yeah.
just after a while you just say, okay, what the hell? I spent 1 week trying to fix this compilation
Oh,
error,
that sounds awful.
and
Yeah.
that was the state of robotics before. And so just so for example, and now we're talking about ROS, but for me the first entry barrier that ROS, you know, removed was the installation. Debian package, use Ubuntu. I don't care. You must use Ubuntu. So I don't overthink it. Oh, my camera make me blurry. Okay, so and then the other one, I remember the first time I saw, a ROS bag. I said, "Oh my God, this changed everything." I said, "Okay, oh, that's so amazing." And also the same for Arvits. So if you think
Yeah. And
about
so
it, it's so
for those who don't know, just if they're not familiar with ROS bags, it's about recording messages that are on the system and then playing them
correct.
back, this
Yes.
kind of thing. So then you don't need your system running and you can see what kind, like replay what occurred, or there's a lot of interesting things you can do with it that speed up development. And Arvis is
Hmm.
for visualization. But yeah, so they changed a lot of things. They made development a lot easier.
Yeah, correct. So this is really the philosophy
Oh,
I
and you're
try
back
to.
in focus now.
Oh, okay, good, good. I don't
Just
know
doing a
if
sec.
the audience will be happy with it. Okay, so yeah, I guess that this is the philosophy I always try to apply, right? And that's the motivation to create Groot.
Specifically, you're saying value, but low barrier to entry. That's what you're saying.
Absolutely.
That's the
So,
philosophy you try to
let me
apply.
rephrase it. Another way I like to express it is whatever is your software or what you're trying to do, programming language or framework or whatever, or library, uh, easy things should be easy to do, and complex and hard things should be possible to do. So what I mean is that
Huh. I like that.
your Hello World example should take 1 minute, 5 minutes, no more.
Hmm.
So start playing, start building something should be very easy. If your Hello World already takes a lot of effort, you are not doing things well.
Yeah.
And but also you need to provide the fact that once you start scaling and start building more complex solutions, you know, it is kind of okay that the complexity also increase, of course, hopefully not exponentially, but logarithmically, right? But so the important thing, you must be able to do complex things. So I cannot promise they will be super
Or else it's a
easy.
toy. Yeah.
Exactly. Otherwise you will hit a wall and say, okay, this solution is not good enough for me, and you need to migrate to something else. So makes simple things easy, make complex things possible.
I like that. Okay.
And so yeah, so coming back to the how this started. This was 3 years ago, and after the project finished, I decided to keep on maintaining it. And there is a lot of work in listening to the community, right? So I was really careful about listening to to the feedback of people. Also, I'm proud to say that some of of the constructive criticism I received drove the direction of BehaviorTree, so the version 3.0. And I think this is really important to have a healthy open source community. You need to be, usually people say, the benevolent dictator, so have a clear direction and not make everybody happy. So you need to have a clear sense of what you want your software to be, but also you need to listen very carefully to what other people think and say, okay, is this any value in this opinion that is different from mine? And for me, there was very often.
Hmm. Can you give some examples?
Yeah, for example, there's a feature I'm particularly, it's one of those features that people at the beginning don't really understand and find annoying. Is that the information in the behavior tree is shared using basically a key value table that's called the blackboard.
Oh, yeah.
And so it's a very simple mechanism, basically a key value, as I said, a key value table, and there is you may have a certain node writing in a key in a field, and then another one reading. For example, you can have an action something like detect object that uh, as output the pose of the object, and then another action that is the grasp object that use that information as an input. So it is classical data flow done very, very simply. And the problem with that is that it doesn't scale because
Oh, that's gonna be my
suddenly,
question. Yeah.
once your tree is huge, you will have something called target that in a certain branch of the tree means the target for the nav2 no navigation, and in some other part of the tree means the target for the move it component. So basically, people
Or you
told
mean
me, hey,
basically you have to make a bunch of manual changes everywhere to
exactly.
change
You
one
need to
thing, which
look
can be really
around
painful.
and start making longer names, like
Yep.
C.
For namespacing
So,
and all sorts of
so the
things.
solution
Okay.
actually was quite simple. That it was basically creating the same of a scope, right? When we have
Ah,
variables, we don't have everything in the global scope. That's bad, right? That's what we learn when we start programming. And at the beginning, we don't understand why, right? At the beginning, we define our int I at the beginning of
yeah.
every function, and or in the global scope, and then say, no, no, don't do that. And
hmm
but this is really the same. So the idea is that basically one big change I applied was to create this this blackboard to make it scoped. So in each
Ah.
subtree, that would be invisible from the outside. So
hmm
you have less problem of collision in the names. So that has some a little
And it's more
plumbing.
modular, kind of implicitly.
It is.
Or
It is. So one of the
hmm
key elements that motivated the design was reusability. So
hmm
the original idea that probably never materialized, but the original idea is that somebody could write an entire tree that does manipulation, and somebody else does an entire tree that does navigation, and potentially can put them together without worrying too much, without checking all the code and see if there is any incompatibility between the two.
hmm
So that was the original idea. Probably that's I'm not sure I got there yet, but let's say that any decision any of my decisions is based on that idea of
hmm
composability.
Yeah. Gotcha. So before we go further with this, I'd love to talk more at a high level about what is a behavior tree
Oh,
and
sure.
like what does it help doing and what are its
Of
major
course.
parts.
Yeah, so behavior tree is simply an alternative to state machine. Nothing more, nothing less, really. Um, so it's a different way to describe, the logic of your robot or your application.
Hmm.
And the idea is that in the state machine are the essence of state machine in terms of what is called the meta model. So I'm not, this is one of those words I don't want to explain because I'm not sure I can explain it correctly. But the idea is that the grammar, let's say it this way, the grammar of state machine is really simple. You have a state and you have transition. So
Yeah.
when
So
I
the parts
explain
are
it, it's
really
very
easy.
simple, right?
So a state
So
machine, you have your different states, and then you have connections between them.
yeah,
And so if you're in this state, you might have a transition to some other state. So I'm in the stop state, and then I get a go thing, and that transitions me to the driving state. And
mhm,
then I'm in the driving state, and I have a brake thing, brake transition, and it puts me back in the stop state. This is like a really simple
correct.
state machine. Okay.
Correct. So the problem with that, and this, I mean, this works fine, right? So that's absolutely fine. The problem is in the scaling, because we as human are not very good at reading this when this scales. So when if you imagine a big state machine that even if we can use a hierarchical state machine that helps a lot.
Hmm.
Actually, we I don't even consider something that doesn't have this kind of composition, so of a hierarchy.
Hmm.
So, so that is a way to lower the complexity. But then there is still complexity in looking, on the screen and looking at all the transitions. So, I think that the cognitive overhead of looking at all the transition, so the
Hmm.
time you spent reading the state machine, doesn't scale very well. On
Hmm.
the other hand, behavior tree try to define a different grammar. So a different grammar where there is the concept of a root of a tree, and something like a signal that goes from the top. If let's imagine a signal that goes from the top of the tree, the root, and then goes down to the leaf of the tree, and the way that you know the way this signal goes from one parent to the from one of the children is based on some kind of logic. For example, if I have a sequence block, a sequence node, a sequence is very easy. Just execute all my children from, let's say, left to right, if we represent it on a screen.
Hmm.
Uh, and if any of these children fails, interrupt the sequence. So there's a very clear semantic, there are very clear grammar associated with this control node, and these require much much less plumbing and connection because a lot of
Oh,
these
much less
connections are
plumbing. Oh, okay.
implicit. Yeah,
Gotcha.
so the mess on the screen is is way less. So the ability to look at your screen and read it, actually, there is a nice property is that, if you ever found yourself, writing this state machine, we spend half of our time doing routing, right? So moving the boxes in a way that looks pretty, right?
Looks whatty? What'd you say?
Pretty. So you
Oh,
know that to avoid the spaghetti look, we
ah,
spend a lot of time saying, okay, I'll put this box here, this other box there. Okay, now I don't have many
yeah.
intersections.
There's certainly a lot of academic papers where they made state machines, and it's just like chaos, and they have lines going from
Yes.
everywhere to everywhere else. So yeah, I see what you mean.
So basically, I'm going to call it this routing. So thinking about PCB, right? So in behavior
Routing like a
trees,
printer circuit board.
yes,
Okay.
exactly, exactly. I'm using
So
this
you have one
metaphor,
thing going
right?
to another. Yeah,
Yes.
perfect.
So instead, in behavior trees, a lot of these, lines are implicit, and you can read as a state machine from top to bottom and from left to right. So
Hmm.
it's almost less like reading text. So it's more familiar for our brain to read, from the start to the end because we do it as we do it with text.
Mm-hmm.
So this, so for me, the value of behavior tree is, really reducing the cognitive effort over the reviewer. Because usually, if you think also about well, I'm a senior developer, and whenever I have the opportunity to work with a more junior teammates, a lot of things, I always focus on the fact that good software is a software that is not software that works, is software because it's software that another human, not a machine, another human can read, right?
Mm-hmm.
Because making a
Definitely.
machine happy is kind of easy, is the easy part. But making the same code in a way that is readable for a human is much harder. And it
Mm-hmm.
what makes the difference between good and bad software.
Yes,
And
definitely. Yeah. And also
and
for future you, for this
I,
kind
oh,
of
absolutely,
workplace.
absolutely. I'm one of those people that can't watch, can look at the code that wrote that I wrote 10 years ago, so or five. So
Mm-hmm.
anyway, my point is that behavior tree, in my opinion, is a better a better approach to basically lower the complexity.
Mm-hmm. Yeah. What it seems to me, so if you think about a behavior tree, it can everything you can represent in a behavior tree can be represented in a state machine, I
Oh yeah.
believe. And so a lot of times, like maybe programmatically, like for you as someone who implements a behavior tree library, maybe like under the core or under the user-facing code, it really is a state machine. Um, is it the case? Or is it
I'm not completely sure because there's a different way to think about your application. And
yes.
also you have a lot of advantages that let me give you another example to show the power of
Or I'll
in my
just finish my
opinion of
thought
behavior
first,
trees.
and then I'd love to hear
Sorry.
that example. I'll just finish my thought first, and then
Okay,
I'd love
sure.
to hear your example. But so to me, what it seems like is the behavior tree is a possibly nicer way of representing the control logic for your robot than a state machine, which can be more complex to work with. Um, and so you can read it more easily, as you were saying. You don't have to worry about like they have conventions for how it's organized and it's hierarchical and it's structured. And you have a few different things that you need to learn for like maybe you have the sequences and you have the I don't know, the other different like the decorators or whatever the components are of it. And once you learn those, you can interpret the grammar of a behavior tree. And that seems like the big advantage of a behavior tree to me. It's kind of like a higher level language on top of a state machine in how I'm thinking about it now.
Hmm. Yeah, you're correct. You're correct. And I'm happy you mentioned decorators because that is an example of something that would be very cumbersome with a classical state machine and is absolutely trivial with behavior trees. So think
Hmm.
about a decorator that is called retry until successful. So basically say keep on running this child node
Hmm.
until it returns a success. So if it fails, try again up to n time. So if you try to implement the same logic with a state machine, you will need a few blocks to express this logic with a
Yeah, it's true.
counter and a count, something that incremented this counter.
I mean, you
And
could have it within the node if it kept parameters between loops. So if it was not, if it had a state in the state machine,
of
you could
course,
do it in one node, or you could do it kind of purely so everything is functional, uh, with several blocks, kind of as you're saying. So I
yeah.
see what you mean. So yeah, it's non-trivial for sure.
And actually now I'm realizing there is a kind of connection with Lisp and macros because something that I always tell to everybody is that don't hesitate to create your own decorators and control nodes. Because sometimes they say, hey, I'd like to have a special sequence that do this or do that.
Hmm.
Can you do it? Feel free to do it. So think about these nodes as words in a dictionary and feel free to make
Your
your
own.
own personal dictionary richer.
Hmm.
So, and this kind of remind me the macros in Lisp somehow.
Yeah, no, I can see it too because you can make things repeat really nice. Or, I mean, you can make things highly reusable with the macros in a way that's very hard to do in other languages. Because you're basically writing code to write code for the macro, and that's just wonderful. I haven't found a good analog anywhere else in the other programming languages I've used. But yeah, so it's highly customizable. So you want this tool, you're going to use it all the time. You can create your new part. I mean, JavaScript does some similar things, and C has their macros, but there's no like autocomplete in them, I think, and kind of painful.
And something else that I mention very often is that the way I look at behavior trees is really like a domain-specific language.
Ah, okay.
So, so this is something that I stress a lot. Whenever I think about it, I think, okay, if this was a programming language, what could I learn from programming language? I learned that the global variables are bad. I learned that if I want to reuse a
Or more than global
certain
variables are bad, scoping is good.
yes, yes, that's correct. So, or that, for example, you have the concept of function. You have this
Hmm.
10 line of code, you
Yep.
wrap that into a function with arguments and
Hmm.
return values. And that's exactly what you do with subtrees. So your subtree is really like a function because
Hmm.
you don't really care what is under the hood. You just see that subtree in the same way you see your full function and you have a certain clear contract about what that function does. That's the same for the for subtrees. Subtrees
Hmm.
could you can have one called grasp object, and under the hood there is a computer vision, you know, several planning and execution of movie. You don't care. You're calling a
Yeah.
grasp object. So here there is the hierarchy and the composability that you have in programming languages.
Hmm. There is, so if you have a, call it like, I don't know, a component or something, say you have grasped the object,
Mhm.
you need to pass that some information, most likely on your blackboard kind of thing, and then you need to make it so that you have the correct kind of information in the correct format for it to accept when it runs that. And I could imagine that would be annoying. But I guess it's
No,
like a
no,
function, but it's
that's actually very well supported. So
hmm.
subtrees as so each node subtrees included as what they are called ports. So ports
Oh, so you have a very clear
are an
defined.
abstraction on
Nice.
top of Blackboard. So, but they have a much clearer contract. So say, hey, this this node or subtree has this input. For example, in the repeat, there is a port that is n times.
Hmm.
So there is an integer. It is strongly typed, so
Oh, that's
it does
wonderful.
have a strong type, and it can even contain a generic gross variable. So it's template, so you can have whatever type you want. You are not limited to in terms of complexity. And you have output ports. So
Hmm.
this is really when you look at it, you just see the input and the output. In the same
Hmm.
way, in a function, you have
It's a
the argument
function.
and the return value.
That's really nice. Okay. I'm a fan of that. So, you were going to say an example earlier? Or,
I was the one about the retry until successful.
ah,
So
okay.
that's the most example.
So then, what are some of the components of behavior trees, and then like use them in a clear example or a concrete example. So, I mean, we have decorators. Decorators are like the retry until doing
Yeah,
something. You have, for example, you could make your own, and it could be some custom logic for how you handle
yeah.
whatever's beneath it.
Or
But
force success. So you say, well, I don't care about the result from the point of view of the rest of the logic. You should always return
always true.
success. So
Like
always
try
true.
whatever.
Or it could be a timeout. So something like, okay,
Ah,
if this action takes more than 10 seconds, abort
mhm.
and stop what you are
Then
doing.
fail if you time out.
Yeah, then
Yeah.
fail. And actually, this brings me to something that I forgot to mention is that the reactivity of the behavior trees. So
What does
behavior
that mean?
trees are reactive.
Okay.
It means that you can create a logic where you check a condition, and when that condition become change, you can maybe abort another part of the tree, another action.
Hmm.
So, for example, imagine when I worked on agricultural robots. Sometimes go to on a field that would take 2 minutes because it was 200 meters away. So you can have a logic to say if at any point during the execution of this action that's called go to, your battery level goes below a threshold, then interrupt what we are doing and do this other branch, a recovery behavior. That is, in that case, would be go back to recharging station. So what is important here is that action are not only return success or failure, they're not atomic, can return running. That means, hey, I'm still doing it. I don't have a result yet. I'm still doing it. And a running action can be interrupted. So this means that you can react to some condition and do recovery behaviors.
Gotcha. How does that work with like I'm imagining, so I'd like to describe the behavior tree a little bit more and then get into this because this is kind of complex, I think. So just to talk about a few of the components for behavior trees. So you have your root. Your root is where everything starts. That's like run. That's like in C++, that's like the main loop or anything else. And so that's just going to keep running until maybe you exit the program or whatever it is. And then beneath that, you will have a bunch of different components that'll help specify actions. So one of them that you already mentioned is the sequence one. And so the sequence, that could be like, I'm going to cook ramen later or something. And so first I need to get out the ramen, then I need to boil water, and I make ramen in a weird order, I guess. I'm boiling water, I get out my ramen, then from there I'm gonna put it in the water, let it boil. It's very sequential. And if for example, I start boiling the water and then I don't have ramen, I guess I'm not having ramen. So that one fails. And then you can kick out if any of the steps fail. That's sequence, correct? That's a sequence one?
Correct.
And in the sequence is composed of leaves, you're saying? So leaves are like the actions to take?
Yeah, well, actually, to be more generic, they're children. So you don't know if it's a leaf or it's
Or
an
just
entire
another.
subtree with arbitrary. So, and that's kind of interesting because you never need to know how complex. You don't need to know who is your parent, and you don't need to really know who are your children. So you just think about your local logic. So I don't care if my child is a leaf or a subtree or another
Just run the
branch.
child, and
So
the
that is
child
the
children have
reason
a
why
specific
I
order.
say that it's intrinsically hierarchical. But you're correct. So the example you made is perfect, and if any of these action is not possible, then the entire
not eating
sequence
ramen.
fail, right? So, and then there's another building block that is the fallback.
Fallback.
Yes. So let's say that basically, if you have children A, B, C, first try A. If it fails, try B, and if it fails, try C. So it's basically saying, okay. And then the example I have from video games is, try to open the door. If you can't, try to smash the door, and if you can't, try to enter through the window. So that is kind of example from the video game world. And so with these two simple building blocks, you can create basically any kind of behavior that also say, okay, if grab the beer, okay, or in the example, okay, no, in the example you just made about the ramen, let's say that if you already turned on the gas to boil the water or the microwave, whatever, you say you can have a fallback. If anything fails, you can have a fallback to say, okay, don't forget to turn off the gas or your stove. So you can react to failure conditions.
So does that mean if I have a fallback, so the way I would structure it is I have a sequence, and the child of that sequence is a fallback one, and that fallback one would have try turning on the gas, check for ramen if we're doing it in that order, and then turn off the gas. So it's going to do one of those. Or no. I guess check for ramen could be. I guess managing the state becomes one of the complex things with this, but maybe you think in it after a
Definitely
while.
needs some. I must confess that sometimes it needs a little bit of training for to do the correct transition, and that's the reason
Yep.
why I introduced the more easier if then else nodes. So condition if it fails to this branch,
Hmm.
and if it succeeded to the other branch.
I see.
So the idea is that if these building block that are the basics, you feel like they're hard to use, there are always other options. So the idea that is that you should be able to find a way to easily express your
Yeah.
intent. And I
I'm
must
thinking,
confess that I'm still working on it, so
yeah, it's a
I haven't
process.
found all the answers.
Yes, I'm thinking now it would be you have a sequence, you have one of these fail ones, then you have another sequence beneath it. And that sequence would be all the steps of getting things ready. And the fail with that would be turn off the gas. So it'd be like the second sequence. So sequence, um, fail, sequence, fail. Um, and in the sequence, it would be turn on the gas, check for ramen, then proceed, put the ramen in it, whatever. And if any of those fails, then you go back and then you turn off the gas and then you go down the sequence. And the next sequence, well, you could see you could put all that in a failure catching one, and then
Yes,
I'd end up
yes.
just ordering ramen is the
And
thing if I want to have ramen.
and here there's also, in my personal opinion, a nice side effect of behavior trees that could be annoying sometimes, but they force you to think about the failure condition. Usually with state machine, you can just say, okay, yeah, this is going to succeed. Then you realize that you also need to add a transition on,
Hmm.
on failure or something like that. But behavior trees constantly remind you, what if
Something
your
fails.
something fails? So it kind of forces you to really think about these recovery behaviors.
How does it work with so those are kind of like if we have those components, we can make a pretty expressive behavior tree. So we have decorators for adding things that are kind of difficult, like retry this many times, or a timeout. Then we have these fail cases where we can try all of these things in hopes that one of them works. And then we can have sequence where we do an order of things. And all of those keep having children and we keep running them. And that's largely what makes a behavior tree. Or are there
No,
other
that's
things?
correct. That's it.
Okay, so we have that representation. How does it, and we have, so if I have a task and it needs to share a variable with something else, it does that through the blackboard, even your scoped blackboards. So we can say these two nodes have access to this, and they're in the same function or something like this.
Yeah,
That
but
means
I always try to force
avoid.
gently force people to think about ports and not blackboard. So say no,
Ah,
tell me very clearly what are your input and output. I want that explicitly in the model of your action. I don't want to be done. I don't want to read your code to know which variable you're accessing.
and what format you want it and everything else too.
So that is really a key and something that actually did differently from the original from the library is that
Yeah.
before to know which variable you were accessing, you should really look at the code and now instead in the model, there's a contract that tells you these are my input and are my output. So a little bit of meta programming there.
Yes, I like that a lot because that's really painful. Like I've done some behavior trees in Python, and Python does a lot of duck typing, which means it'll
Mhm.
just try to run everything and doesn't check the shape of it necessarily before passing it through. And that can be really painful because anytime you want to build kind of a modular behavior tree setup, you have to go read all the other code to try to understand exactly what kind of data structure it wants. So I think having these explicit contracts sounds really nice that you're saying the ports. How does that work from the perspective of the programmer? Um, like if I specify a leaf in the behavior tree and that leaf has like a function signature, but then
Well,
how
if
do I,
to build your own node, basically you inherit from a class. So basically, if you want an action, you have a class my action that is derived from action, and you need to specify a static method. And the static method, and that's the reason why it's static is because you must not need to instantiate the object to access that method, right? Because a property is not a property of the object of the specific instance, is a property of the class. So what you're saying is this class called myAction has these ports. And the way you do it in C++ at compilation time, basically, it's through static methods.
Mm-hmm. So you have these static methods. These require you to not instantiate things, so you can just run this static check to make sure at compilation time that everything is
Correct.
all good for what you're passing. How do you store these variables? So do you use the blackboards for this?
No,
And
no,
it's
that's
saying
a different mechanism. There is a factory. So as you can imagine, it's the classical factory design pattern. And I save in the factory also what I call the manifest. This is basically the model. They say, okay, I know this is my I know that this action has this name and has this ports with this type, this
Yep.
default value. You can even
Yep.
add description.
How do I, so do you have nodes have returns that are stored as like how if I have a node for figure out where an object is and I'm going to
Mhm.
figure it out in XYZ space and maybe like the name of the object or something,
Yeah.
and then I'm going to pass that information to a go grab the object node.
Mhm.
And those nodes, maybe not node, maybe node is not the word for a child,
No,
I
that's
guess.
correct. It's three node.
Tree
So
node. Okay.
so in this case, it's an
But
action.
say it again.
So it's an action is a particular kind of node. So a node
Hmm.
could be the node is the base
Ah.
class, and then you have controllers that can have n children,
Hmm.
decorators that can only have one,
Hmm.
and actions that don't have any
Because
child
they're do something and
because
okay.
they are they do something. And actually, the place in your code where something happening in the system is really in the action.
Yes.
So all the other nodes on the top basically just drive your signal to the right leaf. But
Yep. To the
it's in
right
the
action.
leaf that really something happen.
Hmm. But so how do I get my data of the XYZ position to the go grab it action?
Yeah, that's basically it's very simple. So you have the detect object action. We'll
Yep.
have an input port with the name
Hmm.
of the object, ID of the
Yeah.
object,
Whatever we
and
want.
an output port with the pose. It's
Oh,
a
so you have output
let's say a
ports.
6 degrees of freedom pose.
Hmm.
And from that point of view, you don't care who is going to use this information,
You
right?
just put it
But then
out
you
into
will
the
have
world.
another node that is called the grasp. That
Hmm.
probably is going to be a complex subtree with its own complex rules. But you have something
Yep.
else that need a pose.
Hmm.
So you just use the same word, the same port, in the same way
Just like
when
a
you
normal
connect in
variable.
ROS a publisher and a subscriber, you just use the same name, right? So
Yeah.
that's the same. You use the same name for one input and the other output, and you're reading the same variable.
Huh.
One
So
write and
you
the other read.
so in the definition of the subtrees or of the nodes, you say you're going to look for this variable to fill out your ports. This kind of thing? Fill out your
Yes,
input ports. Cool, cool,
correct.
cool. And
So
it
yeah,
matches
it's
the
you
output
can think
ports
about
of one
bulk
of them.
subscribing,
Yep,
but it's more stateful. So bulk subscribing is your message passing instead here
just goes.
it's really a variable that persists. So let's say that when you read it, you are not consuming it. The value is still there on the blackboard, unless
Mm-hmm.
someone set it to now 0 or whatever.
Mm-hmm. And that's kind of like an implicit blackboard being managed, kind of like you're sending out in the output port this thing that you have this key. The key is the topic that you were saying, and then it's being read in by the other one when it needs it. By the other node, the pickup one, when it is looking for it. So you basically define that. How would you, is there a way for handling if I didn't, so say we have that same example. We have one sensing and one trying to go grab it. What if you made a mistake when you were programming and you didn't have the sensing node and you just have the output, or you just have the one that is trying to go grab it, but it never gets data populated to it?
Oh,
Like,
well,
is there a
that's
compile
there are
time checking for that?
there's a number of error messages you will get. So you do have you know, in your code, when you try to, there is a get input method that will return an error if
Is it
there's no
runtime
input.
or is it compile time?
This is no, this is runtime. This is runtime
Uh,
because you
it's hard to
cannot
make
really.
compile
So
time, probably.
what I do at deployment time is
Hmm.
actually checking if if there is somebody that can write. But I don't
Hmm.
know. I cannot know if that somebody has been executed but at least during the deployment, so during the creation, the startup moment, I do some double checking about you know, if there is a connection between both.
Yeah. See. And then, so thinking about what I've learned about state machines from past interviews,
Hmm.
um, there's this idea of orthogonality that's really nice in state
Yeah,
machines where I can say I'm going to have this state machine running that's going to only handle my robot arm, and I'm going to have this state machine that's going to run my base. How would you do this kind of thing in
there
a
is a
behavior tree?
special node that is called a parallel. So a
Mm.
parallel node execute concurrently all the children.
So you kind of
So
make your thing like two crossing behavior trees if you have
So
two of these.
they're really doing the same thing. They're not the same thing. They're doing different things at the same time.
Hmm.
So you can, for example, you can. A recent example, we had a picnic. You know, while you execute a certain
Hmm.
motion of the arm, at the same time, you start doing the heavy computation for the next movement. So you can do this,
Mm.
you know, at the same time. And in the
But you might
case
as
of
well do them before.
orthogonality, you can
Yeah.
have, you know, a branch that does stuff related to navigation, and another branch that has, at the same time, is folding the arm or doing, I don't know, doing something else. So
Hmm.
the concept here is not, I doesn't call it orthogonality. For me, it's concurrency.
Concurrency. I mean, it's the same thing to me. Basically, I'm
It
just
is,
thinking
exactly. I
parallel
agree.
effectively.
I
But
agree.
okay. Orthogonal to me means unrelated
Yeah,
for this kind of thing. But maybe in some cases they are related. But I guess
they
like if you
could
have a
be.
moving base, you want that to keep moving closer.
Mhm.
Like say you want to pick something up, but it's moving away from you, and so you have the arm reaching towards it, and you have the robot driving towards it, and the arm will grab it when it's can. Like you have two separate things going on there, and you can have them doing concurrent, like
Yes.
behavior trees,
And actually,
effectively.
there will be also this reactive behavior that you need to continuously check if you are at a good distance for grasping or not.
Yes.
So, and if this object during your motion for any reason goes further away, you need to stop your execution and replan. So, yeah,
Hmm.
as I said, I believe, but I might be wrong, that that this is an example of what I said, that you know, complex things like orthogonal behaviors are possible. Maybe they are
Hmm.
not super straightforward, but are possible. You are not limited at the, you know, the
Yeah.
tool doesn't limit you from doing them.
Yeah. Easy is easy, and hard is or hard is possible.
Yes.
I think that's a great way to see these things. And then one other question with behavior trees, how do they handle like events occurring? So you were mentioned like so say there's time something is relating to time in
Yeah.
this. So I want the robot to do something at some specific time. I guess I could have a thing that just says wait until time, but
Here,
and maybe
there's
you could have
really
concurrency so it doesn't block whatever the behavior tree has. But how do you do event driven stuff on a behavior
so
tree?
so. Let's say the default way BehaviorTree works are more like polling. So you have a periodical tick at the root. So imagine that you're sending this signal, and don't be afraid to send it at 1 kilohertz, because the amount of CPU that you're going to waste is going to be
Very little.
absolutely
Because it's just
ridiculously
if
low.
statements, basically. It's like,
So,
is it
so
this? No.
exactly.
Is it
So
this? No. Is it
don't
this?
be
No. And
afraid
then
to call it at at 1
super
kilohertz.
fast.
On the other hand, I recently introduced something like 1 month ago. I recently introduced a new feature that is where you can actually really send a signal, say, "Hey, something changed. Something changed. I don't know what. Something changed in your tree. So interrupt your sleep and send a signal immediately." So what means that, so basically you can interrupt the sleeping and react as fast as possible. So this
Where is
actually
the
make
sleeping occurring? Like,
in
so in
the main
between.
loop. So imagine that you have a main loop that run at the root, and if you have a long action that takes few seconds, this will
Mhm.
keep on returning running. So you keep running and running and running. At some point, that will finish, and you will run another one. And so, since you have a loop, you need to avoid having a busy loop, because otherwise you would use
Oh, so you sleep, and so it's asynchronous, and you defer.
even if it's an if, you need to add a very tiny sleep,
Okay.
just to avoid using 1% of your CPU. So what
Okay.
I did is say that, okay, this sleep is not the POSIX one, is a special one that I can interrupt if I want. If
So
anything
it's you're running
change in the
asynchronous
tree,
stuff. So it's
yes,
async,
so you can really
basically.
react to an event
Mhm.
immediately without any delay.
Yeah.
This is a very recent addition.
Gotcha. It's cool you're still adding things. I think that that's
I
exciting because
do.
it's evolving.
And actually I'm working on the new major version, the 4.0. I'm very excited about it. I hope I'll be able to present it, for the
For
next
Roscon.
ROSCON. Yeah, I hope so. There are a lot of things that I hope will help, making the video tree more readable and, less
Um,
complex.
what do you want to tease any of the features that you're
Yeah,
intending
one that
for?
I'm very, yeah, one that I'm very excited about is the pre and post condition. So
Oh, nice hooks. Yeah.
that is something that you can do already, but that will, once again, that will require a lot of blocks, right? You
Mm-hmm.
can do that, but it's not as easy as I want it to be.
Mm-hmm.
Now, with pre and post condition, you can say precondition. If this value, I don't know, is below or different than 42, do not execute, this action. And the post condition could be something like set this variable to whatever.
Mm-hmm.
And this is where really I'm merging somehow state machines and behavior trees. Because the truth is that sometimes you do need states.
Mm-hmm.
So even if behavior tree is telling you, oh no, don't think about state, think about transition and sequence. The truth is that sometimes you do need states. Sometimes
Mm-hmm.
you say, am I in the recovery state, or I'm so with the post condition and precondition would be much easier to define states. So
Mm.
don't do this precondition, do this only this branch only if you are in that state. Post
Yep.
condition, change your state. So this is where I take the best with two words. Words.
Yes. Yeah, I think that makes sense. To me, like as we're talking, the way that I'm thinking of it is really, it's almost like behavior trees are a domain-specific language on top of state machines, and it makes a lot of common things. So if you want to express fairly complex behavior more easily, a behavior tree seems like a good tool to do that. But everything fundamentally is states, and there's sometimes that you want access to those lower level operations that you have access to with a finite state machine. And so you're kind of adding this functionality back in, which kind of blurs the lines between these two things, state machines and behavior trees.
Correct.
Hmm.
Absolutely correct. Yes.
That's really cool. Now, we have a good bit more time, but I would like to talk about Plotjuggler, which is another one of your large projects, and I'd like to talk about the kind of the connections between
Mhm.
the two projects and how they're different. But tell me a bit about Plotjuggler.
Sure. Plotjuggler is something that I've done, I would say, almost for fun in the last 5 years, and I really worked a lot. And it has been used a lot by the community. I got a lot of nice feedback. And
Hmm.
I, I like to say that it's my love letter to the robotic community. So it is the way I give back to the robotic community. I have a lot of fun doing it. I learned a lot. Um, so basically, it is basically RQT plot on steroids. So for
Nice.
people that are not familiar with ROS, RQT plot is a very, very basic but very useful application to plot the value of a topic, of the fields in a topic. So it's a simple tool, but very useful.
Hmm.
And but the idea is that with Plotjuggler, you can do much, much more. You can, first of all, it is ROS independent. So it has a plugin system, so you can have it, you can include ROS or not, and you can extend the functionalities very easily. So you can support the different kind of file formats, different kind of
Hmm.
streaming messages. Doesn't need, or you can support anything related to ROS, but or you can create your own, I don't know, WebSocket with protobuf protocol,
Huh.
and you can visualize. Basically, you visualize time series. So you can easily, deal with the 1,000, 5,000 time series. It's very easy to navigate through them and put them, in different widget and tabs on the screen. And then you can even run some kind of functions. So, okay, I want to see the low pass filter of this value. Or, I don't know, I want to do the fast Fourier transform of this other value.
Oh, that's awesome.
Oh, I want to compose these two elements and see the average of these three values. So there is also a scripting language that uses Lua that is much easier to embed than Python, and I really like it. So you have a very, very powerful tool to not only visualize data but also analyze data.
Hmm.
And the story about how this started, it was actually when during the DARPA Robotic Challenge, that was now 7 years ago.
You're
It's,
saying the driving one, right?
no,
The
no, the
person.
humanoid one, the one
Oh, the humanoid one.
with the Atlas, the
Yes.
humanoid robots driving and simulating a disaster
Yes. So like
before. So
turning
yeah,
things and
so
getting in cars.
I was in the IHMC team in Pensacola.
Hmm.
Uh, and that was a really amazing team. And
Hmm.
something peculiar is that they had their own software framework that didn't use ROS. It was Java based. So
Yep.
they built
I've
this
used
over
it
the
at
years.
Elodie
Yeah,
in a
and
past
uh,
internship.
and they and they built this absolutely amazing tool to record a lot of logs. Maybe I don't know 10,000 time series at 300 hertz.
Mm.
And then they had this fantastic tool they made to very easily visualize them in plots. And I
Hmm.
said, we need something like this in the ROS community. So
Yeah.
basically started building it. So, year after year became better and better. And, and I'm very proud of it. I say it's kind of silly. So, when you think about it, all the things I've done in robotics, I get so excited about this graphic user interface. But I
Hmm.
don't know, it's like a hobby for me.
Yeah. I mean, it's been so useful for a lot of the community, I think. So it's
Yeah,
a wonderful tool.
and
I
and
don't know.
and I also must thank a lot of companies that either sponsored the Plot Juggler or uh, paid for particular features that eventually were merged to the main branch.
Hmm.
So there was also, some contribution from companies like from autonomous car or drones
Hmm.
that, you know, paid for features, and so it's not I cannot make a living from
With it,
Plotjuggler, but
exactly.
it's a it's a way to have the incentive to keep on delivering new features.
Hmm. Is it is it pretty much just you working on it with
Yes.
occasional external contributors, or
Of course, there are. I get sometimes, pull
pull
requests,
requests and
and
things?
I have a lot of contributors, but I would say that 98% of the code is written by me.
Wow, that's quite a lot. And this one as well, did you focus on documentation, or I guess because it's a graphical
Oh, that's
interface,
that's
it's a
that's
bit
a
different?
fantastic question because in Plotjuggler, the way I measure success is based on the fact that it doesn't need documentation. So the fact
Ah,
that I really force myself to make a tool that is as intuitive as possible, so that just playing around without any complex tutorial, you can start using it and then maybe find the new features. So there is some slides and documentation, but
hmm.
the point for me is that you should start using it, and anything should feel natural.
Hmm.
So drag and drop, very modern UI, not many clicks. So uh, I really think a lot about reducing the complexity and the number of options. So less is
Hmm.
more in some cases.
Yeah, it's like the Apple of RQT kind of thing.
Not completely sure about that, but thanks.
So how do you balance all that? Like, do you
I don't sleep.
Oh, I was
Yes.
yeah, I wasn't meaning in all the endeavors, but with so that's interesting too, your like routines and things, but for actually using or getting users to use RQT, I mean Plot Juggler with like trying to make things as simple as possible yet as powerful as possible. How do you so that's like user experience
Mhm.
related research to me. How do you do that kind of thing?
I guess
Just
I guess
intuitive to you, or what's the
I guess that it's an exercise of empathy somehow.
Hmm.
Trying to put myself in someone else's shoes,
Hmm.
and say, okay, how can I make this simpler, right? Or where should I put this icon? So I'm a one man army. So, but I try to think a lot about there have been many iterations in the style, but I guess it is about putting the important features up front,
Hmm.
and maybe those features that you use less often a little bit more, you know, I wouldn't say hidden, but not
Further away,
occupying too
less
much
accessible
space, no, too much screen space,
for them.
to avoid cluttering the UI.
Hmm.
So,
Gotcha.
and something that I also like to say is that, and now I'm comparing, the difference between Beaver Tree and Plotjuggler. So Behavior Tree is a tool that you want to get familiar with. You want to understand, you want to invest in learning how to use it better as a
Hmm.
programming language, right? So because once you start using it, it really starts becoming a core element of your whole system, robotic
Hmm.
architecture. Instead, plot juggler is something that I always think that is something that should give me the answer I need as fast as I can, and then get
Mm.
out on my way. So Italy Plot Juggler is successful when you launch it, and in less than 1 minute you find the information you were looking for. So
Yeah,
that is so the less you use Plot Juggler,
the
okay,
better.
not if you don't use it at all, of course not. But let's say the shortest amount of time that you need to, you
The
know,
most value per minute kind of thing.
exactly. That's exactly the way I measure the quality of what I'm doing.
Hmm. I like that. I like both of the different ways that you're measuring how useful your software is. And I think it's cool that So these two examples, BehaviorTree.CPP and Plotjuggler, they're very different in their nature, and it's interesting that you've chosen different functions to maximize, in a sense. I like that. I think that that's clever, and I feel like a lot of times you see software where there'll be several different things, but we're trying to maximize the same criteria in all of them. So it feels like a
Mhm.
clever approach to me to take the different priorities in both of the projects pragmatically. I think that's great.
Yeah, thanks. And then, shall we talk about the memes?
The what? Oh,
So,
the memes. Yeah, sure.
so, so, so for those people that have never used Plotjuggler, at the beginning, so probably 3 years ago, there was kind of serious a splash screen when you launch the application. There was kind of,
Yeah, I
very,
remember that.
very, very neat. And then there was a phrase changing every time that it was kind of silly. So and then I said, okay, let's do it for real. So now what I'm doing, I have something like 60 different memes. Uh, every time you launch Plotjuggler, a random one is shown, and they're all jokes about Plotjuggler. So it is the way.
Can you give an example? Like
Uh,
any of the
I,
jokes
I
on
I
the?
should show you. Can I? This is the
Yeah,
good time
sure.
to share
Do
my
it.
screen. Okay, where is the share
It's at
here?
the bottom. Ah,
So
you have
they're
all of them
really
right.
they're really a lot. So
Can
I
you just thumb
sometimes
through them so we could see them?
uh,
Maybe thumb through a couple or
yeah,
your favorite ones.
give me and wait, why can't I move this window here? So okay, this is a simple one. Okay, this is what we
Yeah.
talked we said before. Uh, yeah, the oh, this is my favorite one. So
That's funny.
so and
Yeah.
they kind of stress the fact that Plotjuggler is really the way I see it is really a debugging tool. So um,
Let's see.
basically the idea is that in robotics, in programming, I use a lot GDB, right? I use breakpoints to find errors in my code,
Hmm.
and and but in robotics, very often we cannot use breakpoints because we have this distributed nature and ROS. So we can, if we stop the execution of a controller, then the entire system start behaving strangely. And
Hmm.
so the only way we can really debug sometimes is logging a lot of information and watching this information offline. And
Hmm.
and this is basically the reason why Plotjuggler is useful in my opinion, because the idea is that you must record a lot of data, as much data as you can, and then just comfortably take your time and look at what's wrong here. Is there a saturation of a certain sensor, or is this
So
loop
many
not
things that could
running
be wrong.
periodically? So the idea is that this is the only way sometimes we can debug in a in the robotic
Complex
community.
systems with many parts that are all running at the same
Yes.
time where you can't just put it in a debugger. Yeah. So Plotjuggler is really nice for examining the data.
Yeah. So
Hmm.
so the, and that and this is exactly the kind of experience that I saw at IHMC. So basically, what they used to do, or I guess they still do it, was to say every time so the log was recorded every single time,
Hmm.
but it was on by default, and wherever the human robot would fall, they say that we don't repeat the experiment. We take our time to look at all these thousands of logs and
Hmm.
try to figure out why did it fall. And uh,
Mm.
and this sounds complicated, but it wasn't, because their tool was so amazing. So that is exactly what I
Hmm.
tried to recreate, and I think I succeeded. Is
Nice.
The idea is if you have a failing experiment, you must have collected enough data to know more or less where the bug is.
Hmm. Let's see. Is there any things that the IHMC software did that you would like to add to Plotjuggler?
Not anymore.
You've done them all. Yeah,
I've done everything and more.
nice. Do they use Plotjuggler? Do you know, or you
I
haven't
have no
been?
idea. No, I
Ah,
don't know. I don't know.
gotcha. How do you So when you are working on Plotjuggler, and actually this the same goes for Behavior Tree CPP. So these are both large projects. And so, I mean, most of these, I think Behavior Tree CPP, was it similar to Plot Juggler in that you are the primary person who has
Oh yeah,
done most of the code? So like
yeah,
98% of the code or whatever
something like that.
is you.
Yes.
So for both of these projects, um, it strikes me as someone who likes to build stuff a lot myself that the best projects for an individual are not really big projects. Like it's not projects of integration. Like you can let Microsoft do that or some
Hmm.
big company that'll combine like this and that and other thing. Because it's a lot of work to connect all of them. Whereas as an individual, it seems really good to find very specific use cases and build something very targeted for a specific problem because you can
Hmm.
move really fast
Yeah,
in this kind of thing.
correct.
How do you balance the scope of both Behavior Tree CPP and Plot Juggler so that it's kind of nice for you as a as an individual developer?
So, okay, for Plot Juggler right now, I'm mostly driven by sponsorship. So
Mm,
let's say that I listen to, of course, it is some bug report. I take care of it, but new features right now are mostly sponsored features. So I actually
mm,
have I'm working right now, spoiler alert, on a very
oh,
exciting one that is being sponsored by a drone company. Uh, so if everything goes well, that will be released the next month.
that's
So so also because I believe that in the state where it is, it's kind of done. So
mm-hmm,
you can extend the number of file format it can read. I recently added a format from Apache Arrow,
mm-hmm.
so you can using plugins you can easily extend the functionalities, but the community can do that if they want to. If they want me to do it, I guess that they should
They should fund. Yeah.
yeah, fund it. So that is so basically, I'm kind of happy with the current state of Plotjuggler. So I don't need to make it bigger.
Mm-hmm.
It's not a need. It's something that would be nice,
It has
but
reached its use case.
yes, I think
You've
so.
done
I
it.
think so.
Mm-hmm.
And on the other hand, in Behavior Tree, I still think that I still believe that I'm not quite there. I think that there's still something that I can make simpler. So my
Mm-hmm.
real goal to make things easier, uh, so to lower the complexity as much as I want, is something that I hope version 4.0 will do better.
Mm-hmm.
So I decided to invest more time there. And what I did was, in the last maybe 3 months, I've tried to contact a lot of users, especially industrial users,
Yeah.
ask for their pain points, their feedback. So I spent time listening to them and trying to understand what could be valuable for them. And
Hmm.
actually, so
What kind of things did you hear from them?
well, what I heard a lot is that BehaviorTree.CPP is great, but sometimes the Groot, that is this graphic user interface, is really the most valuable tool for them because
Mm-hmm.
it's what make the difference between having a senior developer building behavior or someone maybe a little bit more
More
junior
junior.
that with this drag and drop graphic user interface, it's a little bit more inclusive somehow. Um, and so the
Okay.
feedback I got a lot is that they love Groot, but also they feel like Groot is hitting its limits
Mm.
in terms of scalability. And I'm painfully aware of that. And I'm trying to find way to, you know, fix that. But that I think that the only way to make that possible is making some kind of
A new.
commercial version
Oh.
or because I reach the limit of what I can humanly do in my
Yeah,
spare time. So I need that either there's some kind of funding and someone hired to do Route 2.0, or that very valuable piece of software will become more and more obsolete.
gotcha. What do you think of like have you had any people work and like mentored them on projects and like is that a good model for getting
Yeah,
additional
yeah. I
people
must
on it or
confess that
building?
sometimes I'm approached by companies that need some help with BehaviorTree.
Mhm.
So once again, right now my number one focus is looking at picnics. So I use a little bit
Yeah.
of my spare time to do that. But I can see that there is interest in supporting people that because this is one of those technologies that once you decided to use it, we talk about entry barrier, but now let's talk also about the barrier about leaving it for something else, right? So after
Mm,
you invested time in
very hard.
making your logic with it, transitioning to something else, it would be painful. So
Mm.
makes sense sometimes to knock on my door and say, "Hey, David, can you help us with this?" So I helped some companies in the past and also
Hmm.
right now, giving some suggestion. Hey, why don't we do this in this way?
Yeah,
Hey,
because it
these things
becomes
we
a
did that can be
critical
simpler.
dependency. Hmm.
And so yes, I do some mentoring.
Gotcha. Do they ever contribute back, or would it like, would you ever see this following kind of the same model as Move It has with Picnic, where it's like you start out as kind of the solo developer or solo maintainer, and then there's enough demand that you hire additional developer, or the open robotics model, which has done kind of the same thing, and then scale from there, more companies interested. Do you think this would ever follow this path?
Might be, might be.
Mm.
Let's say it this way. I'm looking around to see, I'm seeing the momentum growing, so more and more users using this library, and
Hmm.
it could be. So for the time being, what I'm doing is, saying, "Hey, I'm here. If you need any help, let me know, and
Yep.
let's see if this, where this goes."
Hmm. What do you think? So, I guess, so what is the back end of Plotjuggler? Is it RQT and
No,
or
it's Qt. It's Qt.
oh, it's Qt. Oh yeah, yeah. Yeah,
Yes.
of course. Gotcha. Well, did you ever look into web technologies for this kind of thing? Kind of more like Foxglove
Sometimes,
or
yeah, I'm, I'm currently looking at WebAssembly.
oh,
So, because this is really a limitation of mine that I don't know any JavaScript and
uh,
I I'm too lazy to
to
learn
learn
it.
it. Not too
So
bad.
I'm looking at WebAssembly. There is this new technology that allow to compile C++ or Rust into code that can run in a browser. So I'm dipping my
To get your
toes
feet into that.
there, but not in a foreseeable future.
Gotcha. I really like TypeScript. TypeScript is fantastic for just all the typing and everything. It makes JavaScript less messy, it feels like. But let's see. Where do you think these are gonna go? Like when you think 5 years down the road, what do you see for Behavior Tree CPP and then Plot Juggler also?
Okay, so well, for January, first, I'd say that I'm quite happy where it is right now. So,
It's gonna
my
chug
goal
along.
when I started, I said I want Plotjugger to be installed in all the computer where ROS is installed.
Hmm.
So probably I'm not there, but I think I'm not that far away either. So I believe that in the community is a tool that is well known
Hmm.
and used by I don't know how many people, but I guess in the thousands
Do you
or
have any
hundreds.
analytics on it or?
I do have some analytics from GitHub, but I think that this doesn't really represent the real number because a lot of people get it through Debian packages.
Yes, it's
But
true.
uh, but uh, let's put it this way. Every time I talk to somebody, they know about Juggler. So my bias, what's called it, the survivor
Confirmation bias.
confirmation bias. So I believe that you know, I'm quite happy where it is, and probably can grow even more. But I'm happy. Probably,
That one's
probably,
stable.
I
Yeah.
guess we could start using it outside robotics. I mean, there's no reason why
Oh yeah.
a company. Actually, I'm being contacted by a company that doesn't use any ROS, and they want to use it to connect it to their machine that is publishing data at 1 kHz. Say,
Gotcha.
can Plotjuggler do that? And say, yeah, no problem, easy.
Awesome.
So I think it can become a platform that is more generally used
Hmm.
whenever you need to visualize data either from file or from streaming. And then in terms of BehaviorTree.CPP, I must confess that I'd love it to become the standard, you know, planning, uh, let's say, paradigm in robotics. I'd love to.
Hmm.
So what I can do about it is just try to make it better and better, easier to
Hmm.
use, more tutorials. Once again, listening to the community and to what their complaints, and try to really understand and make it, because at the end of the day, it's a tool that is not for the machine, it's for the humans. It's a tool
Hmm.
that need to be easier for humans, and because you can, you know, you can express your logic with a bunch of if then else you know, with the 7 level of indentation.
Yeah.
So from
And
the
it'll
point of
be.
view of the machine doesn't care about the complexity of the way you
Nope.
express the behavior. It's really the human, the bottleneck to understand complex behavior and to write and read complex behaviors. So that is what I'm trying to do better and better. And yeah, I love it if it's used by the ROS community.
Hmm. Is it currently used by Nav2 or any of the large?
Oh yeah. So and actually I should probably thank them because you know, probably one of the reason why it became so popular recently is because NAV2 use it to define recovery behaviors.
Hmm.
So a lot of people find out about behavior trees, CPP thanks to NAV2. So yeah, I'm very grateful about that.
Oh yeah. Do you do any like marketing or anything to like try to get out to people or like
Yeah, we
how have
recently
you
have
reached
done
people?
probably in April I've done the first workshop. So I tried to
Ah.
say, hey, if you're interested and you want to make your voice heard,
Mhm.
there's this workshop and probably, you know, yeah, I want to create a community. There's a special forum now. Uh, it's not super active at the moment, but I'm doing these steps to, you know, involve people and create better uh, resources, tutorials.
Yeah. Did you ever think about or try doing like a Discord community or a Slack
Oh
community?
yeah, yeah, I had one.
Ah, okay.
I had one.
Hell yeah, awesome. We can I can put a link to that in the show notes. Let's see. So 5 years from now, you're just hoping it'll chug along. You'll keep trying to grow interest for Behavior Tree CPP, um, and working towards lowering that barrier to entry for, and maybe focusing on the graphical side of things
Yeah.
with. Okay, awesome. So I'm struck by the fact that you have two very large, like effectively side projects for this. Um, can you just tell me a bit about, I don't know, like how you work on side projects or how you think about this in terms of your career or just how do you think about side projects?
Well, first of all, I must say that they've been a very effective personal branding tool. So, you know, I've done a lot of things in robotics, but the fact that these tools are known by many people, it's really a way to be more visible in the community. Um, so they really helped me to reach, to give me also some job opportunities because, I always say, look, I'm not a GUI developer, a graphic user interface developer, and Plotjuggler, I do it for fun. I'm really a roboticist, so I can do complex algorithm for you or navigation, perception, whatever. But that is a marketing tool, so a lot of people know about me thanks to that. So I would suggest if you have the passion for programming and you enjoy doing side projects, it worked for me to find new opportunities. And also and even if you don't get those opportunities, I mean the reward, in the open source community, sometimes the coin that is used to pay you is gratitude. So I can't count the number of people that wrote me an email saying, "Hey, thanks for Plotjuggler. You helped me in my thesis," or
That's
people
nice.
people generally are grateful for what I did, and this motivates me a lot. And so I would suggest anybody that has the interest, you're not obliged to, but if you enjoy doing it as I do, we encourage, scratch your own itch, doing something that you like, and then don't be afraid to show it off to the community. Hey, I'm this tiny thing, but maybe you find it useful. And so yeah, and then personally, the way I find time is basically when it's 9 p.m. I need to decide if I'm watching a Netflix series or program, and sometimes I decide to program.
Nice.
That's not for everybody, but for me, I like it. I mean, and I think that a lot of people that are into software development and knows that it could be a little bit addictive sometimes,
That
because there is
flow.
this cycle of frustration and reward. And I must confess that with at least for me, with this graphic user interface, the cycle of reward is a little bit faster. So, you change the color of a button and I say, oh, how nice is that? And
Yeah.
you're kind of proud of yourself. Instead, I have more stories of frustration with the software algorithm and control algorithm that don't are not stable, and I don't know why. So that
Yeah.
in robotics, I have more frustration than happiness sometimes.
Yeah. So if you were to start a new side project, what would you make sure you do really well to try to get community buy-in and things like this? Like if someone wanted to start a new project, what are some like really important things for them to think about and focus on?
Well, first of all, it would be two things. First of all, try to solve a problem that either you have or somebody else has. So think really about the problem you're solving. Don't build framework. The smallest is your work, the more useful it is. Because sometimes, the granularity, having a library that does only one thing but really, really well is important. Then invest time into documentation, and also, maybe very stupid logo in your README file, something that gives the feeling that it's not just some code that you uploaded on GitHub, forgot about it. So making the number of people that will try your software is not, I don't know how proportional, if it's directly proportional or exponentially to the quality of your documentation. And this is something also I can say about ROS, right? ROS 1 had very good, from day one, very good documentation. Anybody always say that. So documentation is important, and then for certain kind of product, not all the products, only for certain kind of software. I say product because I think about products. there is a concept I like. That in startups there was this term called minimum viable product, right? The MVP. And there's something else I've read once on an article. There is the minimum likable product. So something that connects with your users like. And for me personally, this means was a way to joke with my user, right? To have this running joke with my users, connect with them, and I'm not saying that other people should do that, but sometimes you're appreciated also for something else that is not just the result of your of a certain function or certain language. Sometimes. So
Hmm.
yeah, this is not for all the projects. Sometimes if you're doing a common filter library, you don't need any any special logo,
Like, yeah, fun
but
to
you need
assembly.
documentation.
Yes. Do you what's your fun? So for Plotjuggler, it was on the loading screen. It was uh, the memes that come up. What do you have one for Behavior Tree CPP?
Well, for BehaviorTree.CPP, I took it more seriously. So there is the examples on the documentation are taken from video games, and then the Groot, the splash screen of Groot is kind of more serious, but then it is Groot and subtitle the fancy behavior tree editor.
Huh. Yeah,
So
fancy
there's
one. Yeah.
yeah, the fancy one. So even there I have a tiny joke, but as I said, it really depends. At the end of the
Hmm.
day, it's for me, Groot. For example, what I like in Groot, even if there's no jokes, is that I like that it's a very polished UI.
Hmm.
In my opinion, it's really modern compared to others. And,
Nice.
I guess is what I like most.
Hmm. Let's see. Where do you think robotics is headed in the next like 2 to 5 years, say?
Okay, 2 to 5 years is not much, because because
You can do bigger if you like,
I
right?
I I I I will tell you why, because all the prediction we did in 2005 were wrong. All the prediction we did in 2010 were wrong. So I we so we see. Anyway, so robotics, definitely what I'm seeing already is that ROS 2 is receiving the kind of recognition that we always want from the industry, that we
Hmm.
always wanted for ROS. So uh, I see ROS is already the standard for most of us, but I think that that would be even more established in also in old-fashioned robotics, and not just
Hmm.
startups. And in terms of developing robotic software, I would say that there will be some major blocks that will be the lower. When you need navigation, you have Nav2, and
Hmm.
Nav2 does a lot of things, and the way it's growing and improving is really astonishing. Then, if you
Hmm.
do manipulation, you have Move It, so no doubt about it. Hopefully, if you need to do task planning, and you have behavior trees, we will
Hmm.
see. But the idea is that there will be some clear, mature de facto standards in the main blocks of the architecture. And
Hmm.
I'm kind of excited about also the work is being done at Open Robotics about fleet management, the Open
Hmm.
Fleet Management project.
Yes, I have to do an interview on that in the near future. Don't know what's
Yeah,
next yet,
I'm
but
kind of
would
excited
love to
about
cover
that, because
that.
that was really a missing link, I
Hmm.
think. Um, and also in perception of things. So I would say what I hope to see in 5 years is very well established standards and a little bit more focus on architectural design.
Oh.
So right now, in the at the beginning we always focus on the individual functionalities, And then as a late folks, we think about how to put all these things together. We think about the system architecture. So what I hope is that once these individual functionalities becomes commodities, I mean, you still need to be an expert, of course, but let's say that you get from zero to decent uh,
Mhm.
faster, then there will be more idioms and experience about software architectures.
Ah, cool. Yeah, I think that's a good point that we'll kind of we're at a fairly low level, and then we can once the low level is easy to achieve because we use NAS2 and BehaviorTree.CPP and Move It and these kinds of things, then we can worry more about or start to try out a bunch of different ways of building our software, and then we can experiment with what actually works well,
Yeah,
and then we'll come up with better architectural practices and
yeah,
the abstractions
yeah.
and things.
Yeah, architecture that are resilient. There is
Hmm.
some, debuggability also and
Hmm.
recovery if anything fails. So, these are things that comes always later, right? We always focus on the proof of concept, but I'm more excited about how can I control a fleet of 100 robots and be sure that if any of my robots is misbehaving, I have the information to find what's going on. So those are
Hmm.
all pieces that we are not talking about much in the robotic communities that I hope to see in the next years.
Yeah, for sure. There are some exciting rumblings of that. Like my interview with Christian Fritz earlier is kind of like getting towards fleet management. What we're doing at Open Robotics is very exciting. And then there's some paid services like Amazon Greengrass and whatever, but it will be cool to see how we move as a community and what kind of
Mhm.
standards, what ways of doing things we find to be best. So, yeah, I bet that will mature a lot in the next
And
5 years or so.
and now something between me and you, because nobody's listening. Actually, do you have the feeling that also the robotic community is kind of special because it's very centralized? I mean, if you compare to other communities, for example, in the web technologies, there are a lot of, you know, lot of information, a lot of frameworks, and there are different communities in, web technologies. But in our, we are really centralized. So really, Ross is kind of the sun, and everything is kind of circling around it, orbiting around it. That's my feeling, and that's great because it's also a way to reconnect it to other people and increase the
Hmm.
momentum of having good libraries because sometimes in the past in the early years of Ross I remember people criticizing, oh yeah, I don't know about if this software I find that this Ross node it's well maintained, correct, wrong, I don't know, but after working in some larger companies, I can tell you that sometimes even proprietary code is not that good. So,
Yes. Oh, for sure.
so just the fact that it's free doesn't mean it's bad. And actually, I can see more and more quality in
Oh, definitely.
the open source community.
Yes, I think you're right. I mean, just even with a bunch of open source software, and I don't know how specific I can speak, but things getting certified to high safety levels and things like this are making it so open source software is in really like Move It has a collaboration with NASA in this kind of thing. Like that's a huge win for open source.
Yeah,
Same with Open
absolutely.
Robotics, these
How
kinds of
exciting
things.
is that?
And
Raw
then one,
space.
yes, seriously. One thing I'm excited about too is I feel like well, my dad is really into astronomy, and so he builds telescopes, or he I don't know. But so I see so many opportunities there for where robotics could be useful, and I think there's a lot of other industries that are kind of reinventing the wheel, and robotics is, as we're becoming more and more established, there are more places where robotics technologies will bleed into, and I think it'll kind of rise all ships in a sense, like a
Yeah.
rising tide rises all ships. So I think that would be very cool. But is there any contact info? links, resources, anything you'd like to share with our listeners?
Oh, well, there is the two GitHub pages for the two projects. That would
Mm-hmm.
be enough, I guess. And there you can find, all the other links about the full, the discourse and the tutorials and everything else. So that would do.
Awesome. All right. It was great speaking to you.
Yeah, nice.
Bye,
Thanks a lot
everyone.
for having me. Bye
My
bye.
pleasure. Bye. Thanks for listening to this conversation with Davide Faconti. Thank you again to our founding sponsor, Open Robotics. See you next time.